Hello everyone. This is a review for the practice final exam. What I'm going to do for each question, I'm going to just highlight the keywords and the formulas being used. So if you have the practice exam posted on Brightspace and you read the first question, you will see something similar to this in the exam. Here they tell you that the bank believes 7% of people will not make the payments on time. So you're given a certain percentage. P is 7%, and that's not making payments on time. And they tell you they're going to test this on a sample of 200 loans. So the sample is 200. The question is, what's the mean and standard deviation for the proportion? So you're looking for mean and standard deviation for proportion. And this is the key word here. It's not any mean or standard deviation. It's the mean standard deviation for proportion. So make sure that it's the mean and standard deviation for proportion. The mean for proportion would be whatever the percentage that's in the question. So it would be percentage given. That's your mean in this case. The standard deviation for proportion, it would be P times 1 minus P over N. So P 1 minus P over N. So it's the 7%, 1 minus the 7% divide 200. So you take your calculator and you find the percentage of 0.7 times the 1 minus and divide 200 and you square root it. That gives you 0.184. And then they say, what's the distribution? You've seen this before. The distribution in this case is binomial distribution. So you say it's binomial distribution. With n equals 200, p equals 0.7. What we just did, we did an approximation to normal distribution. So we did approximation to normal, and that gave you a mu and a sigma. And your mu is tilde 0.7, and sigma is the one we just did, the 184. Okay, the assumptions needed for this and what are the conditions if the conditions are met. Now, in order for you to do this approximation, so assumptions needed for approximation, it's something called success failure. So you basically take n times p and n times 1 minus p, hoping to see if this is more than 10. So you go 200 times 0.7, and you take 200 times 1 minus the 0.7, and you see what you get. When you do it for the first one, it's 14, and when you do it for the second one, it's 186. Both of these numbers exceed 10, so yes, condition is met. And then they ask you a probability question. They say, what's the probability that you get over 10 not make payment? So let me just recap. The question started with a certain percentage people not making payment. You're testing this on a sample of 200. They ask you to do approximation by doing the mean and standard deviation for proportion. Mean, standard deviation for proportion. And we found the mean for proportion to be 0.7, whatever the percentage is. And we found the sigma for proportion to be P1 minus P over N. And when we calculated this, it was 0.0184. And the question now, what's the probability over 10%? So what's the probability that you get a P hat, a certain percentage, or observed percentage, or sample percentage? What's the probability that your certain percentage exceeds 10%? In order to do any probability question in statistics, we need to find the z number. And the z number would be, in this case, p hat minus the mu p over sigma p. This is the formula we use when you do mean and standard deviation proportion. So it would be the 10% minus the 7% over the 184. So we do the math here. The number is 163. 163, and so in terms of z is 163, and if you guys remember, this is 1 minus the table. So you go to the table, you look for this, and your answer would be 1 minus whatever you get from the table. Okay, so this is the first question in the sample practice. I'm going to read question 2. Question 2, they tell you that they're preparing a survey, confidence interval. They tell you with an error at most 4%. 4%. Sometimes they tell you within 4%. At 95 confidence interval. At 95 confidence interval. And the question is, how large sample needed? So the question is asking for n. When you're asked for n, you're going to apply this formula. Sample size equals z star over me squared times 50 times 50. Now, what is z star? I told you before how you get this z star. You go to the t table. You go to the degree freedom, infinity, and you'll see in the degree freedom infinity, they start with 80%, 90%, 95, 98, 99. They tell you 95, so you pick this number for the 95. And you'll see that it's 1645. So your answer would be 1645 for the z-star. ME stands for margin of error. And this is always given in the problem. They will tell you something with an error 4%, within 4%. Sometimes they say plus minus 4%, but it's always given. So you put 4%, or you put it as a number, 0.04. You square times 50 times 50. So again, you take the calculator and you do the math. So 1645. And divide by 4. You get 422.81. It doesn't matter what you see after the decimal point. We always round up. We always round up. So you say sample. Ignore what you see here and add 1. So the sample must be 423. So this is the answer for question number 2. Now question number 3 is true false. There's not much I can talk about for this question. So read it. It's pretty much there's nothing to talk about, so read it. I think their answers are posted. If the answers are not posted, I might actually text them or send them to you. But I think the answers are posted. So I'm going to go to question 4. Now, in question 4, they say 74% of 1644 randomly selected college freshmen return to college next year. So you have 74% of 1644 of a sample of 1644, 74% of 16 selected freshmen. These are the percentage of returning students. Now, estimate the national rate proportion of freshmen returned. So if this is the percentage of return of only 1644, so you know that there are probably going to be more than 1644 students, first year students. If this is the percentage of a sample, this is only the percentage of this. So this is percentage of a sample. What would you consider the national percentage to be? Well, if this sample is large enough to estimate that the percentage of the national is going to be the same thing, 74. Now, after this, verify that the conditions are met. This is the same conditions we saw in the first question. Success, failure. So you take NP and N minus P. So you take 74, 1644, and 1 minus the 74, 1644. And we're hoping that both numbers will be more than or equal 10. The first one is 12, 16, 5, 6. That's more than 10. And if you do the second one, you get a 42744. That's also more than 10. So both numbers are in fact more than 10. And then the question C, construct a 95% confidence interval. 95% confidence interval for proportion, you're going to use this confidence interval. P hat plus or minus Z star, P hat 1 minus P hat over N. Again, this is confidence interval for proportion. So if you see a question, say, find, this is the key word, find confidence interval for proportion, you use this. Now, you put everything together. So your P hat is the sample proportion given. Z star, I told you, that's from the T table. You go to degree freedom infinity with the number that goes with the 95, that's 196. And then you go 74, 1 minus 74 over the sample, and this sample is 1644. You bring the first number down, you only do the calculations, whatever comes after the plus minus. So you do this in your calculator, and make sure that you try it yourself to know that you can find the answer. This would be 212. So you open brackets, here you minus, and here you add. So when you minus them, I'll take you down to 74, minus 212, take you down to 7188, and when you add, it takes you to the 7612. I have to stop this video here because I don't want it to take more than 17 minutes because it's take time to upload. So I'll stop when in part 2, I'm gonna refer back to the beginning of the question, go over it again, and we'll complete the question. Thanks, guys.